I bet you didn't know that mathematics is the key to unlocking the mysteries of the universe. Yes, you heard me right, mathematics. We often think of math as this rigid, dry subject confined to textbooks and classrooms. But beneath the surface of equations and formulas lies a universe of fascinating stories, surprising connections, and mind-boggling concepts that underpin our very understanding of the cosmos. Over the next few chapters, we'll delve into 10 surprising facts about the basis of mathematics, from its humble beginnings to its profound impact on the world today. We'll uncover hidden truths, challenge our assumptions, and hopefully ignite within you a passion for this fundamental language of the universe. So buckle up, get ready to expand your mathematical horizons, and prepare to be amazed by the surprising beauty and power of numbers. This is 10 surprising facts about the basis of mathematics. Our journey begins with a concept so fundamental, so seemingly obvious, that we often take it for granted, the concept of zero. Now you might ask, what's so special about nothing? Why does zero hold such significance? Well, in the grand tapestry of numbers, zero is not simply an absence of value. It's a powerful idea, a mathematical revolution that changed the course of history. Imagine a world without zero. How would you count large numbers? How would you represent nothingness? How would our entire system of place value function without this crucial digit? The ancients, believe it or not, struggled with this concept for centuries. Cultures like the ancient Egyptians had placeholder symbols for zero, but it was the brilliant minds of ancient India that truly embraced zero as a number in its own right. Around the 5th century CE, Indian mathematicians, those architects of numbers, gifted the world with the concept of zero as we know it today. This wasn't just a philosophical musing, it was a practical tool, a key that unlocked new mathematical possibilities and transformed the way we understand the universe. Now, let's travel back in time to ancient Greece, a civilization that revered knowledge and wisdom above all else. This was a society where philosophy, science, and the arts flourished, creating a rich tapestry of intellectual achievements that continue to influence our world today. The ancient Greeks were pioneers in many fields, from politics and philosophy to mathematics and astronomy. Their intellectual contributions have left an indelible mark on the fabric of human knowledge, resonating through the ages and shaping the way we understand the world. In the bustling city of Samos, around the 6th century BC, a legendary figure emerged who would forever change the course of mathematics and philosophy. His name was Pythagoras, a man whose ideas and teachings would echo through the corridors of time. Pythagoras wasn't just a mathematician. He was a philosopher, a mystic, and the leader of a secretive society known as the Pythagoreans. This group believed that numbers held the key to understanding the universe, and they dedicated their lives to uncovering the mathematical principles that governed the cosmos. The Pythagoreans saw mathematics as a sacred path to enlightenment, a way to connect with the divine order of the universe. They believed that by studying numbers and their relationships, they could unlock the secrets of existence and gain a deeper understanding of the world around them. Among the many contributions of the Pythagoreans to mathematics, one theorem stands out for its elegance, simplicity, and profound implications. This is the Pythagorean theorem, a fundamental principle in geometry that has stood the test of time. The Pythagorean theorem describes a relationship that exists in every right-angled triangle. It states that in such a triangle, the square of the hypotenuse, which is the side opposite the right angle, is equal to the sum of the squares of the other two sides. This simple yet powerful equation, often written as A2 plus B2 equals C2, has become one of the most well-known and widely used formulas in mathematics. It is a cornerstone of geometry, providing a foundation for countless other mathematical concepts and applications. Throughout history, students and scholars alike have memorized and applied the Pythagorean theorem, using it to solve problems and explore new ideas. Its influence can be seen in fields as diverse as architecture, engineering, physics, and even art. The impact of the Pythagorean theorem extends far beyond the realm of mathematics. In ancient Greece, it was a symbol of the harmony and order that the Pythagoreans believed existed in the universe. They saw the theorem as a reflection of the underlying structure of reality, a testament to the power of numbers to reveal the truth. The Pythagorean theorem also played a crucial role in the development of astronomy and navigation. Ancient Greek astronomers used the theorem to calculate distances and angles, helping them to map the stars and understand the movements of celestial bodies. Sailors and explorers relied on these calculations to navigate the seas, charting new territories and expanding the horizons of human knowledge. In architecture, the Pythagorean theorem has been used to design and construct buildings with precise measurements and proportions. The ancient Greeks applied the theorem to create structures that were not only functional, but also aesthetically pleasing, reflecting their belief in the beauty of mathematical harmony. The influence of the Pythagorean theorem can even be seen in the art of ancient Greece. Artists used geometric principles to create intricate patterns and designs, incorporating the theorem into their work to achieve balance and symmetry. This fusion of mathematics and art is a testament to the holistic approach of the ancient Greeks, who saw no distinction between the two disciplines. Today, the legacy of the Pythagorean theorem continues to inspire and inform. In classrooms around the world, students learn the theorem as a fundamental part of their education, gaining insights into the nature of space and shape. Architects and engineers use the theorem to design and build structures that are both functional and beautiful. Astronomers and physicists apply the theorem to explore the mysteries of the universe, pushing the boundaries of human knowledge. The Pythagorean theorem is more than just a mathematical formula. It is a symbol of the enduring power of human curiosity and the quest for knowledge. It represents the timeless pursuit of understanding, a journey that began in ancient Greece and continues to this day. As we explore new frontiers and make new discoveries, the principles embodied in the Pythagorean theorem remain as relevant and inspiring as ever. So, as we reflect on the legacy of Pythagoras and his remarkable theorem, let us remember the spirit of inquiry and discovery that drove the ancient Greeks. Their passion for knowledge and their belief in the power of numbers have left an indelible mark on the world, a testament to the enduring impact of their intellectual achievements. The story of the Pythagorean theorem is a reminder that the pursuit of knowledge is a timeless endeavor, one that transcends the boundaries of time and space. It is a journey that connects us to the past, informs our present, and shapes our future. As we continue to explore the mysteries of the universe, let us carry forward the legacy of the ancient Greeks, honoring their contributions and building upon their foundations. In conclusion, the Pythagorean theorem is not just a mathematical principle. It is a symbol of the human spirit's unending quest for understanding. From the ancient city of Samos to the modern world, its influence can be seen in every corner of our lives. It is a testament to the power of ideas to transcend time, inspiring generations of thinkers, dreamers, and explorers. As we look to the future, let us remember the lessons of the past and continue to seek out the knowledge that will shape our world. The Pythagorean theorem is a beacon of that quest, a reminder that the pursuit of truth and understanding is a journey that never ends. And in that journey, we find the true essence of what it means to be human. We've talked about zero, a concept that eluded humanity for millennia. Zero, a seemingly simple idea, was a revolutionary breakthrough in mathematics. It allowed for the development of algebra, calculus, and the binary system that underpins modern computing. The journey to understanding zero was long and arduous, with many ancient civilizations grappling with the concept. The Babylonians had a placeholder for zero as early as 300 BC, but it wasn't until the 5th century AD that the Indian mathematician Brahmagupta defined zero as a number in its own right. This breakthrough spread through the Islamic world and eventually reached Europe, transforming mathematics forever. We've delved into the elegant truth of the Pythagorean theorem. This theorem, attributed to the ancient Greek mathematician Pythagoras, states that in a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. This simple yet profound relationship has countless applications in geometry, physics, engineering, and even art. The Pythagorean theorem is a cornerstone of mathematics, demonstrating the power of logical reasoning and the beauty of mathematical relationships. Now, let's journey to a number, a ratio, that has captivated mathematicians, artists, and architects for centuries: the golden ratio. This mysterious and fascinating number, often denoted by the Greek letter phi, f, approximately 1.618, has been the subject of wonder and admiration for millennia. The golden ratio is not just a mathematical curiosity. It is a fundamental principle that appears in the natural world, human art, and architecture. Its unique properties and aesthetic appeal have made it a symbol of harmony and beauty. Often represented by the Greek letter phi, approximately 1.618, the golden ratio isn't just a number on a dusty chalkboard. It is a mathematical constant that has intrigued and inspired thinkers across different fields. The golden ratio is defined as the positive solution to the equation f at 2 equals f plus 1, which can be derived from the Fibonacci sequence. This sequence, where each number is the sum of the two preceding ones, converges to the golden ratio as it progresses. The golden ratio's unique properties make it a cornerstone of mathematical beauty and elegance. It's a relationship, a proportion that appears again and again in the natural world and throughout human artistry. The golden ratio can be found in the spirals of galaxies, the branching of trees, the arrangement of leaves, and the patterns of various flowers. It is a universal constant that seems to govern the structure and growth of living organisms. This remarkable ratio also appears in human creations, from the proportions of ancient Greek statues to the design of modern buildings. The golden ratio's pervasive presence in both nature and art is a testament to its fundamental significance. From the arrangement of seeds in a sunflower, where each seed is positioned at an angle of approximately 137.5 degrees from the previous one, creating a spiral pattern that optimizes space and sunlight exposure. This arrangement, known as phyllotaxis, is a direct manifestation of the golden ratio. The same principle can be observed in the arrangement of pine cones, pineapples, and other plants. The golden ratio's influence on the natural world is profound and far-reaching, shaping the growth and form of countless living organisms. To the spiral of a nautilus shell, the golden ratio emerges, whispering tales of nature's elegant design. The nautilus shell grows in a logarithmic spiral, with each chamber proportionally larger than the previous one, following the golden ratio. This growth pattern allows the nautilus to maintain its shape as it grows, providing an efficient and stable structure. The golden ratio's presence in the nautilus shell is a striking example of how this mathematical principle underlies the natural world's beauty and complexity. And humans, in our never-ending quest to understand the universe, have incorporated this ratio into our art and architecture. The golden ratio has been used by artists and architects throughout history to create aesthetically pleasing and harmonious designs. During the Renaissance, artists like Leonardo da Vinci and Michelangelo used the golden ratio to achieve balance and proportion in their works. Architects have also employed the golden ratio in the design of buildings, from ancient temples to modern skyscrapers, to create structures that are both functional and beautiful. The ancient Greeks, those pioneers of geometry and aesthetics, recognized the captivating power of the golden ratio. They used it in the design of their temples, sculptures, and other works of art, believing that it embodied the principles of harmony and beauty. The golden ratio was considered a divine proportion, reflecting the order and balance of the cosmos. Greek mathematicians like Euclid and Pythagoras studied the golden ratio, exploring its properties and applications in various fields. We see its influence in the Parthenon, its dimensions carefully crafted to reflect this divine proportion, a testament to the belief that beauty and mathematics are inextricably intertwined. The Parthenon's design incorporates the golden ratio in its columns, facade, and overall structure, creating a sense of balance and harmony that has captivated visitors for centuries. This iconic building stands as a symbol of the ancient Greeks' mastery of mathematics and their appreciation for the aesthetic principles that govern the natural world. The golden ratio continues to inspire modern architects, artists, and designers. In contemporary architecture, the golden ratio is used to create buildings that are not only functional, but also visually appealing. From the proportions of windows and doors to the overall layout of a structure, the golden ratio helps achieve a sense of balance and harmony. In digital design, the golden ratio is used to create aesthetically pleasing interfaces and layouts, enhancing the user experience. Artists and designers across various fields continue to explore the possibilities of the golden ratio, pushing the boundaries of creativity and innovation. The golden ratio's influence extends beyond architecture and art. It can be found in the proportions of the human body, with the ratio of various body parts approximating the golden ratio. This has led to the belief that the golden ratio represents an ideal standard of beauty. In nature, the golden ratio can be observed in the patterns of hurricanes, the shapes of galaxies, and the structure of DNA. Its presence in such diverse and fundamental aspects of the universe suggests that the golden ratio is a universal principle that governs the harmony and order of the cosmos. Throughout history, the golden ratio has fascinated and inspired some of the greatest minds in science, mathematics, and art. From the ancient Greeks to the Renaissance masters, and from modern scientists to contemporary artists, the golden ratio has been a source of wonder and exploration. Researchers continue to study the golden ratio, uncovering new applications and insights into its properties. The interdisciplinary nature of the golden ratio, bridging the gap between mathematics, science, and art, highlights its unique and enduring significance. Today, the golden ratio is taught in schools and universities around the world, inspiring new generations of students to explore its mysteries. Educational programs and interactive exhibits help people of all ages understand the significance of the golden ratio and its applications in various fields. By studying the golden ratio, students gain a deeper appreciation for the interconnectedness of mathematics, nature, and art, and the universal principles that govern our world. As we look to the future, the golden ratio will continue to play a vital role in shaping our understanding of the world and our place within it. Emerging technologies and innovative designs will harness the power of the golden ratio to create new possibilities and solutions. From sustainable architecture to advanced digital interfaces, the golden ratio will help guide the development of future technologies that are both functional and beautiful. The timeless appeal of the golden ratio ensures that it will remain a source of inspiration and discovery for generations to come. The golden ratio, a special number that transcends time and space, continues to captivate and inspire us. Its presence in the natural world, human art, and architecture is a testament to the profound and universal principles that govern our existence. As we continue to explore and understand the golden ratio, we uncover new layers of beauty and harmony that connect us to the cosmos and to each other. The journey of discovery is never-ending, and the golden ratio will always be a guiding light in our quest for knowledge and understanding. Thank you for joining us on this journey through the wonders of the golden ratio. Until next time, keep exploring, keep discovering, and keep finding beauty in the world around you. From the elegance of the golden ratio, we turn now to a revolution in mathematics, a tool so powerful it would change the course of science and engineering: calculus. This branch of mathematics, developed independently by Isaac Newton and Gottfried Wilhelm Leibniz in the late 17th century, has become the cornerstone of modern science. It allows us to understand and describe the world in ways that were previously unimaginable. Calculus is not just a set of rules and procedures, it is a way of thinking, a language that helps us describe the universe in terms of change and motion. Forget your preconceived notions of boring equations and tedious calculations. Calculus is far more than that. It is a dynamic and powerful tool that can be used to solve real-world problems. Whether it's predicting the trajectory of a spacecraft, optimizing the design of a bridge, or understanding the spread of diseases, calculus is at the heart of these endeavors. It is a subject that is alive with possibilities, constantly evolving and expanding as we discover new applications and insights. Calculus is about change, about motion, about understanding the very dynamics of our universe. It provides the tools to analyze and predict the behavior of systems that are constantly changing. From the simple motion of a pendulum to the complex interactions of particles in a quantum field, calculus allows us to model and understand these phenomena. It is a subject that is both beautiful and profound, revealing the underlying order and structure of the natural world. Before calculus, mathematicians were like photographers, capturing static snapshots of the world. They could describe the shape of an object, but what about its motion? How could they understand the changing position of a planet, the growth of a population, or the flow of a river? These were questions that could not be answered with the tools of classical geometry and algebra. Calculus provided the framework to address these questions, allowing mathematicians to move beyond static descriptions and into the realm of dynamic analysis. They could describe the shape of an object, but what about its motion? How could they understand the changing position of a planet, the growth of a population, or the flow of a river? These were questions that could not be answered with the tools of classical geometry and algebra. Calculus provided the framework to address these questions, allowing mathematicians to move beyond static descriptions and into the realm of dynamic analysis. What about the ever-changing dance of planets and stars, the ebb and flow of tides, the intricate workings of the human body? These are all phenomena that involve continuous change, and calculus provides the tools to understand and describe them. By breaking down complex motions into infinitesimally small steps, calculus allows us to analyze and predict the behavior of systems that are constantly changing. It is a subject that is both beautiful and profound, revealing the underlying order and structure of the natural world. Enter calculus, not as a single invention, but as the culmination of ideas brewing for centuries. The development of calculus was a gradual process, building on the work of many mathematicians and scientists who came before Newton and Leibniz. From the ancient Greeks to the medieval Islamic scholars, the foundations of calculus were laid over many centuries. It was a period of intellectual ferment, and two towering figures emerged to bring this new mathematics to life: Isaac Newton and Gottfried Wilhelm Leibniz. It was a period of intellectual ferment, and two towering figures emerged to bring this new mathematics to life: Isaac Newton and Gottfried Wilhelm Leibniz. These two men, working independently, developed the fundamental principles of calculus. Newton's approach was based on the concept of fluxions, while Leibniz developed the notation and methods that are still used today. Their contributions were complementary, and together they laid the foundation for a new way of thinking about mathematics and the natural world. These weren't your stereotypical mathematicians, toiling away in isolation. Newton and Leibniz were deeply engaged with the scientific and intellectual communities of their time. They corresponded with other mathematicians and scientists, sharing their ideas and building on the work of others. Their discoveries were not made in a vacuum, but were part of a larger movement of scientific inquiry and discovery. They were men of boundless intellectual curiosity, driven to unravel the mysteries of the cosmos. Newton, a scientific polymath, was also a master of optics, mechanics, and even dabbled in alchemy. His work in these fields informed his development of calculus, providing him with the tools and insights needed to understand the behavior of physical systems. Newton's laws of motion and universal gravitation, which are based on the principles of calculus, revolutionized our understanding of the natural world. His work laid the foundation for classical mechanics, and his contributions to mathematics and science are still felt today. Leibniz, a philosopher and diplomat, made significant contributions to logic, linguistics, and even invented a calculating machine. His work in these fields informed his development of calculus, providing him with the tools and insights needed to understand the behavior of physical systems. Leibniz's notation and methods are still used today, and his contributions to mathematics and science are still felt today. His work laid the foundation for modern logic and computer science, and his contributions to mathematics and science are still felt today. These were men of boundless intellectual curiosity, driven to unravel the mysteries of the cosmos. Their work in calculus was just one part of their larger quest to understand the natural world. They were driven by a desire to uncover the underlying principles that govern the behavior of physical systems, and their contributions to mathematics and science are still felt today. Their work laid the foundation for modern science and engineering, and their contributions to mathematics and science are still felt today. From the complexities of calculus, we journey now to a sequence of numbers so simple, so elegant, that it seems almost like a mathematical magic trick, a trick that never fails to amaze. Forget your complicated equations and abstract theorems. The Fibonacci sequence, with its deceptively simple pattern, will take us on a journey from the pages of ancient texts to the intricate patterns of the natural world, patterns that are both mesmerizing and profound. Here's the setup. Start with 0 and 1. Add them together, you get 1. Add the last two numbers, 1 and 1, you get 2. Keep going, always adding the last two numbers in the sequence. 0, 1, 1, 2, 3, 5, 8, 13, and so on, stretching towards infinity. Simple, right? But within this simple pattern lies a world of mathematical wonder and endless possibilities. This sequence, named after the Italian mathematician Leonardo Fibonacci, first appeared in his book Liber Abaci, way back in the 13th century, a time when mathematical discoveries were just beginning to unfold. We often think of algebra as this language of x's and y's, equations and formulas, but it wasn't always this way. Imagine, if you will, the ancient Babylonians around 2000 BC. They were grappling with mathematical problems, just like us, but they didn't have our modern notation. Instead of letters, they used words like length and width to represent unknown quantities. Can you imagine trying to solve a complex equation with that? It's like trying to write a symphony using only the sounds of nature. Impressive, but ultimately limiting. Few concepts are as mind-bending, as simultaneously alluring and terrifying as infinity. It's a concept that has fascinated philosophers and mathematicians for millennia, pushing the boundaries of what we think we know about the universe. Think about it. A number larger than any number you can imagine, a line that extends forever in both directions, a universe that might just go on and on without end. Infinity challenges our intuition, which is rooted in the finite world we experience. Geometry. It's a word that might conjure images of protractors, compasses, and perhaps a touch of high school math anxiety. But beneath those familiar tools lies a profound journey of human thought, a quest to understand the very fabric of space and shape. Our story begins with Euclid of Alexandria, who lived around 300 BC. Euclid wasn't just a mathematician. He was a master architect of logic, and his masterpiece, The Elements, stands as a testament to the power of deductive reasoning. We humans have always loved a good secret, haven't we? From ancient ciphers used by Roman generals to the Enigma machines of World War II, the quest to hide and uncover information has been a constant throughout history. But what many people don't realize is that behind these secret codes, behind the clandestine messages and the cloak and dagger intrigue, lies a powerful tool: mathematics. For centuries, mathematicians toiled away with pen and paper, their minds grappling with complex equations and intricate theorems. Calculations were laborious, time-consuming endeavors, often requiring painstaking precision and a healthy dose of patience. But the advent of computers in the 20th century ushered in a new era, a revolution that transformed the very fabric of mathematical exploration. From the humble beginnings of counting on our fingers to the mind-boggling complexities of quantum computation, mathematics has been an integral part of the human journey. It's the language of the universe, a tapestry woven from logic, patterns, and abstract beauty. And as we've explored in this series, the basis of mathematics, from its fundamental principles to its ever-expanding frontiers, is a testament to the power of human curiosity and our insatiable thirst for knowledge. But remember, my friends, the story of mathematics is far from over. It's a story that's still being written, a story that each and every one of us has the potential to contribute to. So keep exploring, keep questioning, and keep marveling at the wonders of the mathematical universe. Because within its infinite depths lie secrets waiting to be uncovered, secrets that have the power to reshape our understanding of the cosmos and our place within it. The journey of discovery is ongoing, and as always, keep looking up, keep wondering, and keep dreaming.